Hey everyone, today we're going to dive into a really fundamental problem in our digital world. How can we actually trust our data? I mean, in an age where we're drowning in information, how do you know what's real, what's original, and what's been messed with? It's a huge question, and it's leading us to a completely new way of thinking, an architecture built from the ground up for verifiable data.
And it really all starts with this one kind of chillingly simple idea. Just think about it for a second. Every big data breach, every story you've read about fake financial reports or altered medical records, they all have the same quiet starting point. We're not talking about some Mission Impossible style heist here. It's way simpler, and honestly, way more dangerous than that.
And that right there, that's the core of the problem. You see, a system that can't tell the difference between its original, pristine state and a manipulated one is a system that's just waiting to fail. The change could be tiny, a single number in a spreadsheet, one pixel in a photo, or a single word in a contract. And if the system itself can't spot the change, then for all intents and purposes, that lie becomes the new truth.
So let's really dig into this hidden flaw, right? This isn't about building stronger firewalls or coming up with more complicated passwords. It's about the very foundation of how we store and check our digital information. The problem is literally baked into the architecture of most traditional systems.
So that leads us to the real question. What if data could have its own permanent identity? You know, like a unique signature that proves it is exactly what it says it is, right from the second it's born. If you can answer that question, well, you change everything. Okay, so the first piece of the puzzle, we need to give our data its own DNA. It's a great metaphor, really. Just like every living thing has a unique genetic code, every single piece of data can be given its own unique identifier that is completely tied to its content. This isn't just slapping a label on a file, it becomes part of its very being.
Now, the techie term for this DNA is a content hash, but let's just call it a fingerprint. It's way easier to picture, right? Basically, a complex algorithm reads the data and spits out a totally unique string of characters. This string is a one-of-a-kind signature for that specific file, and for that file only.
So how does this actually work? It's a really simple but incredibly powerful three-step process. First, as soon as data hits the system, it gets encrypted. Standard security stuff. Second, the system instantly generates that unique fingerprint. And third, and this right here is the magic, if even a single byte of that data is ever changed, even one tiny little bit, the fingerprint doesn't just change, it completely breaks. It becomes totally unrecognizable.
What you get is this super simple black and white result. There's no gray area. When you check the data against its original fingerprint, it either matches perfectly, boom, it's verified, it's authentic, or it's broken, which instantly exposes that it's been manipulated. There's literally no way to secretly edit something and get away with it.
Okay, that's great and all, but a fingerprint is only useful if you have a totally secure original copy to compare it against, right? I mean, where do you store that ultimate source of truth? And that brings us to the second pillar of this whole architecture, the unbreakable anchor.
Now, this is where things get really clever. We all know about cloud services like Amazon S3 or Google Cloud. They're built to be fast and easy to access. In this new model, that's still their job, handle speed. But the truth, that original untouchable record, that's stored somewhere else entirely, on a decentralized network. That means it's secured across tons of different computers instead of just sitting in one place.
The real power of this anchor is its permanence. Think about it. Individual servers can get hacked, they can go offline, they can be shut down, but the reference, that anchor, on the decentralized network, it stays forever. It creates a system where what you originally uploaded is exactly what exists, period. And here's the kicker. It's not locked away in some vault. Anyone can check it and verify the data for themselves.
So this is where it all comes together. When you combine that unique data's DNA, the fingerprint, with this unbreakable anchor, you get something totally transformative. You get a system that creates trust, not by accident or by a promise, but by its very design.
And this distinction is so important. Look, we get flooded with promises about security from companies every single day. This is different. This is not a promise. It's an architectural fact. The system is fundamentally built not just to protect data, but to make it constantly and publicly verifiable.
This is the idea that just flips the whole paradigm of digital trust on its head. Instead of having to rely on a company's word or how strong you hope their firewalls are, you rely on pure mathematical and architectural certainty. The trust is just baked right into the system itself.
So I want to leave you with this final, really powerful question. If we can build systems where the authenticity of, I don't know, medical records, property deeds, scientific research, or even just a photograph is mathematically guaranteed and anyone can verify it, just what does that unlock for us? It points to a future where trust is no longer a leap of faith, but a verifiable fact.